Now that we've loaded the tools on our turret, and we also know the dimensions of each of them, which we've already loaded into our CNC, we are reaching a very important part of our project that I've mentioned to you many times.
I would say that we're talking about referencing the tool.
Almost. What we want to reference is the turret, and knowing the lengths and characteristic dimensions of each of the tools. I reached the condition of...
Don't tell me, I know. The precise location of each of the tools in the CNC.
Perfect. And so, with this, we come to what is known as setting the axis. This may be a fairly complex procedure, but I'll explain it to you in detail so that we can clear up any doubts.
Perfect, thanks.
What I want to reference is this. The truth is that there are many ways to do this. I'll show you a fairly standardized way, and then once you've practiced, you will be able to do it in the way you think is best. First of all, what I want us to look at is the configuration of this particular lathe. The turret rotation axis is parallel to the spindle rotation axis. There are some lathes in which the turret rotation axis is perpendicular to the spindle rotation axis.
Wait, Jorge, does this have any consequences on the procedure? Because I'm pretty sure that in my company, I have a turret with a perpendicular axis.
Conceptually, it is the same. There are some small differences, but conceptually, it is the same. To set the axis, we are going to use a piece that will act as a reference. Once we have our piece mounted on the machine, we're ready to start with the setting. In this case, of the z-axis.
Okay.
First of all, what we're going to do is machine the front of the piece. Then, for the second step, we're going to move away from the piece without moving the z-axis. In this way, we're going to ensure that the axis that we want to set does not change its position.
I think I understand where we're going, Jorge. By keeping it on the z-axis, what we want to do is see if the z value on the screen of the machine is the same as the length of the piece measured from the front of the plate.
Exactly. And this is where we come to the third step of our procedure, which consists of measuring the length from front of the plate to the front of the piece with the greatest possible accuracy. Would you let me measure it?
Yeah.
If we measure it with the gauge, we get 187.7.
But the z value on the screen is 1034.782. Does this mean that it's badly referenced?
Yes and no. Before making this decision, we have to make a little calculation. What we want to do is reference the turret, so that the distance shown on the screen is the sum of the length of the piece and the characteristic size LZ. Now, if this value is equal to the one on the screen for Z, it is correctly set. If not, we will have to correct it.
I think that there's a problem, Jorge. Because with this calculation, it's still wrong. We have to correct it, don't we?
That's right. Press the offset button, select the G54 coordinate system, go to the Z coordinate, press the right arrow, into the value, the result of the sum we did before, and finally, press the measure key. What did this do? It moved my coordinate system to the front of the plate. Therefore, now the position is 194.01.
Super clear, Jorge. What I do is use the piece whose dimensions I know so as to reference perfectly and exactly the location of the turret. Don't we have to do the same with the x-axis now?
What we have to do is a very similar procedure. In this case, what we're going to do is polish the surface of the piece to remove any imperfection that it has. We're going to move away from the piece without moving the x-axis. Once we're outside, we're going to measure the diameter of the piece. We'll do the calculation and we'll compare it with the on-screen values that the CNC gives us, and correct if necessary. Once we've set the z-axis and the x-axis coordinates, we only have to check that the coordinates match what we programmed. Where did we put the reference system?
On the plate.
So what should happen is that if I move the tool and touch the front of the piece, the value on the screen should be exactly the same value that we calculated.
Shall I check? Let's go. There it is.
Excellent.
And is the value correct?
Yes, perfect. Then we can say that we set the axes well.
So, Jorge, we saw how to set both the x-axis and the z-axis. Essentially, what I have to do is machine, measure, calculate, compare, and if it's necessary, correct. Is that right?
Perfect. And with that, we have finished this section.